Okay. Shall we start now? So, welcome back guys, welcome to NEET World. So, in this session we are going to continue with the motion in a straight line of the next part. Okay. So, till now what we have seen, let us recap the things. Okay. Yes. So, the topic which we are going to see is, and which we are seeing is motion in a straight line. This is the topic we are seeing. Okay. So, till now we have completed the basic definition, we have completed, like what is distance, what is displacement, and what is the reference frame, what is rest, what is motion, right, and then what is velocity, speed, and then acceleration, what is instantaneous velocity, instantaneous acceleration, and those things we have completed right now. Then we went to the topic one dimensional motion. Right now, one dimensional motion. So, straight line, no, straight line, we are discussing about 1D, right now, one dimensional, yes, 1D, right now. So, when it goes for the 2D, the next chapter is coming, that is motion in a plane. Okay, that one we will discuss in the upcoming sessions. Next, what we have discussed, the kinematic equation under this, right now, and what else we discussed? A motion in a vertical motion, no, vertical motion we have discussed. So, under vertical motion, what are the things we discussed? Free falling body we have discussed, free falling body we have discussed, and then object has been thrown upward. So, we have discussed some things, almost these things we have discussed. So, now we are going to the next topic, which is graph. Okay. Now, we have discussed about these things, and what is the use of graph, you can ask, what is the use of graph, and what is the use of graph in physics. Okay. So, first we will see the basic terms of graph, and then what is the use of graph in physics, and what is the link between this chapter and the graph. Okay. Let us start now. Yeah. So, graph. So, graphs are visual tools to understand how quantity, like one quantity changes with another quantity. Okay. If x changes, y changes. Yes, no? Yes or no? If x is equals to 1, like for example, let me take an equation. For example, I will take an equation which is, yeah, y is equals to 2x. Okay. For example, if I take x equals to 0, y will be equals to 0, no? X equals to 1, y is equals to 2. X equals to 2, y is equals to 4. X equals to minus 1, y is equals to minus 2. Yes, no? As x changes, y also changes. So, how we are plotting a graph? Graph is nothing but between two variables, I will say. Yes, no? Between two variables. So, if I take these terms, no, if I take these terms, I will plot first what is x. With respect to y, I will plot. Then what is x? X equals to 1, y equals to 2. I will plot that one. And then x equals to 2, y is equals to 4. X equals to minus 1, y is equals to minus 2. X equals to minus 2, y is equals to minus 4. I will plot the graph and get the, I will plot the point and get the graph for that. Right now? So, understood now? Like Graphs are visual tools to understand how one quantity changes with another quantity. Okay. So in physics we often relate time with position, velocity, acceleration, pressure, etc., whatever it is. Okay. So here if I take a time, I will relate with position. If I take a time, I will relate with velocity. If I take a time, I will relate with acceleration. Okay. These are the main things we are going to see in this chapter. Okay. Leave about the pressure. We are going to concentrate on time versus position, time versus velocity, time versus acceleration. Okay. And the next thing is plotting a distance versus time graph helps us to identify if motion is uniform or non-uniform. Okay, the basic example. Okay, basic example. Now we will go into the topics. That is coordinate axis. We have seen 2 points, no, like one is x and one is y. Z also is there. Yes, no, in graph x, y, z. When we talk about the coordinate axis, no, yes, the x axis is horizontal and usually represent the independent variable. Okay. So independent variable means like time. Okay. And the y axis is vertical. Vertical in the sense this is my vertical and this is my horizontal. No. So y axis will be dependent variable, x axis is independent variable. This thing you should keep in mind. Okay. Horizontal is nothing but x axis, vertical is nothing but y axis. Okay. X axis is always independent, y axis is dependent. So dependent means distance is there. So distance will be depends upon the time, right? How much time if I take x is equals to where's the pen? Yeah. X is position or distance will take. Okay, distance is x is equals to 2t square plus 3t, right? No, x is depends upon the time. Yes or no? If I substitute time t is equals to 1, x will be 2 plus 3 5, right? No, x is depends upon the time. Okay. So the point 0, 0 is called the origin. So if I draw the axis, no, this is my x axis, this is my y axis, and this is my point origin, no, 0, 0. Yes or no? 0, 0. Example, in a speed time graph, the time is on x axis. I told you, no, time should be independent and distance, velocity, acceleration are dependent. Okay, dependent. So if I take speed versus time, speed should be in y axis, that is v. Time should be in x axis, that is t. Okay, got it na? The next one is slopes. Okay, slopes is nothing but a slope of a line is the tangent of the angle made by the line with positive x axis in the anti-clockwise direction. Anti-clockwise direction in the sense, if this is the clock is like this. So if I go from 1 to 2, 2 to 3, it is clockwise. If I go reverse manner, anti-clockwise, no. Yeah. First we will read the points here. It tells us the rate of change, like how much the graph has been changing. Whether if I take a velocity versus time, no, yes or no, velocity versus time, or whatever, acceleration versus time, or displacement or position versus time. If object is moving with some velocity 20 meter per second, okay, equation has been given and you have substituted, you got at t is equals to 1 second, object is 20 meter per second. At t is equals to 2 seconds, object is 25 meter per second. T is equals to 3 seconds, object is 15 meter per second. So it has been increased and it has been decreased. So whether if equation is not there and only graph is given, I need to find whether it is increasing or decreasing. Okay, by using slope I can find whether the quantity is increasing or decreasing? By using tangent. Okay, tangent is nothing but I draw a line for a diagram which is, which touches up one point of the graph, no, or diagram. Yes or no? If I draw a circle, if I want to draw a tangent for the circle, it touches only one point. Yes, no, tangent is nothing but when I draw a line to a diagram, it touches only one point of the diagram. Okay. So suppose if this is my graph, okay, this is my graph. Suppose whatever it is versus time versus velocity or acceleration or displacement. Okay. So if I take displacement or position or displacement versus time, no. Okay, position versus time. If I take a tangent is nothing but a slope. Slope is tan theta, will say, no. What is tan theta? Adjacent by hypotenuse, opposite or opposite by adjacent? Opposite by adjacent, no. What is opposite here? X. Y, this is y axis, no. Y by x will say. This is y axis, no, and this is x axis, no. Don't confuse between this. If I write x, this is x axis, not this one. Like this is y axis and this is x axis. So tan theta will be y by x, which is nothing but x by t. Position versus time, no. What is, displacement versus time will say. Displacement by time will give velocity, right? No. If object is going like this, if I consider this point, is velocity is increasing or decreasing, I want to know. Okay. So what I should do? I should take a tangent here. I should take a tangent here and draw a horizontal line. So make an angle theta over here. Okay, make an angle theta over here. And the thing we should understand is when 0 to 90 degree, it is positive, it is increasing. Okay, 90 to 180 degree, it is negative, it is decreasing. Okay, that one we'll discuss in the next upcoming slides. Okay, this one you understood, no? Slope of a line is the tangent of the angle made by the line with positive x axis. So whenever you are drawing a tangent, it should be with respect to positive x axis. Okay, and it should be in anti-clockwise direction. Okay, this is x axis, tangent it should be from anti-clockwise direction and it should be with respect to horizontal, that is x axis. Okay, and it tells us the rate of change, like how much the graph has been changing. So mathematically slope is nothing but tan theta. So where 0 to 180 degree. Okay, now this is the thing we should understand. So from 0 to 90 degree slope is positive, 90 to 180 degree slope is negative. Exactly 0 or 180 slope is 0, which is object is at rest, will say. Yes, no? 0 to 9, exactly 90 it is not defined. Okay, not defined. Basic thing you should remember is whenever angle between 0 to 90 slope is positive, which is increasing, 90 to 180 slope is negative, which is decreasing. Exactly 90 it is undefined, 0 or 180 slope is 0. Okay, you can note this. Done? Go for the example, we will see one example. Done, no? Yes. So there is an example. Suppose if theta equals to 60 degree, okay, let me write here. Yes. if theta is equals to 60 degree, they are asking slope. No, slope is nothing but tan theta, right? Tan 60 is root 3, right now root 3, which is positive or negative? Positive, which means slope is increasing, right now slope is increasing. Leave about that one. Now theta equals to 135 degree, which is nothing but tan of 90 plus 45, no, I can say like this, 90 plus 45 is 135. So how can I write it as 90? No, 90 in the sense tan should be converted to cot. Keep in mind, whenever you are getting 90 or 270, sin should be changed as cos, cos should be changed as sin, tan should be changed as cot. Remaining 0 and then 180, 360. Sin will be sin only, cos will be cos only, tan will be tan. Okay, only these two cases, 90 or 270, tan should be changed as cot, right now cot. What is the remaining thing? 45. So when I see the coordinates, no, all silver teacups, 90, 180, 270, 360, 90 plus theta, second quadrant, no, second quadrant, tan is positive or negative? Negative, it is only sin is positive, right now. So minus cos, cot 45. Okay, what is the value of cot 45? 1. So minus 1 I will get. So is it negative or positive? Negative, which means slope, slope is decreasing. Yes, no? Got it? How to do? Mainly you can take a note of this. This is very important thing, okay? 90, 270, 0, 180, 360. So I will write here, sin will be sin only, cos will be cos only, tan will be tan only. Okay? Can we go for the next one? If it is completed, we will go. Done? Yes. Slope using dy by dx. Okay. Suppose till now we have seen slope is nothing but tan theta, right now tan theta. And one more method is, if equation is given, okay, equation is given, slope of a line or a curve y is equals to f of x. What is f of x? It is a function of x, we will say. At a point is given by dy by dx. For example, if y is equals to 4x plus 7, what is the differentiation of 4x plus 7? I will get 4. So constant slope, no, there is no other term with respect to y. 4 is there. If 4x will be there, it is variable slope. It is constant, no, only 4 is there. If I substitute any value, no, I can't do anything. So it's a constant slope. If y is equals to 2x square, like if you differentiate, you will get 4x, which is variable slope depending on x axis. If x equals to 1, slope will be 4. Y x equals to 2, slope will be 8. Okay, you got it now? What I am saying? So constant slope and variable slope. So another method of finding slope is dy by dx. Okay, if equation is given. Done. We'll go for the next one. Done. Types of slope in graph. Okay, so positive slope, negative slope, zero slope, infinite slope. Right now we have discussed about that positive, negative, and then zero, infinity. No, so if I draw a graph like this. Okay, if I draw a graph like this, suppose if I want to find at this point, exactly I will draw a tangent like this. So if I extend the horizontal line, it is increasing, that is positive, we will say. So line rises from left to right. Left to right, it is rising, no? So if it is positive, suppose line is from like this, line falls from left to right, it is falling, no? It is falling line, it is rising line. So falling line will be positive, falling line will be negative, rising line will be positive. Okay, or else the angles I can use. One thing is theta is from 0 to 90 positive, 90 to 180 negative, or else line rises from left to right positive, falls from left to right negative. So left to right falling in the sense this is my axis. So falling, this is the angle, no? What is the angle? Greater than 90. So it is negative, right? Understood, no? So zero slope in the sense horizontal. So horizontal line which is parallel to x axis. So infinite slope, vertical line which is vertically in with respect to x axis, makes exactly 90 degree, no? Yes, no? So here what we can understand, horizontal in the sense 0 or 180, angle 0 or 180, vertical 90 degree, here it is greater than 90, here it is less than 90. So positive, negative, 0, and it is infinity. Okay, line rises, it is positive, falls negative, exactly parallel means 0, vertical means infinity. Okay. Yeah, you can see here a diagram is given. So it is rising, no? Positive. It is falling, no? Negative. Vertical, infinity. Parallel, 0. Okay. So point 1 shows positive slope. Point 1, which is this point 1. Point 2, 3, 4. Got it now? So this is the diagram. You can note this diagram. Got it? So is there any doubt till now? We have discussed, one thing we have discussed is a meaning of slope, and what is the basic thing of graph is having coordinates x and y, and x axis is independent variable, y axis is dependent variable. Okay. Slope is nothing but it's a tan theta. If theta is less 0 to 90 positive, 90 to 180 negative, exactly 90 infinity, 0 or 180 it is 0. Okay. And one more method is differentiation method if equation is given. Okay. So the next thing is position and time graph. Okay, position and time graph. So time should be in x axis, position should be in y axis. So in this diagram, if you see here, it is parallel, no, parallel to x axis, that is time. So it's a stationary object, rest, no, rest, 0 will say, no, angle is 0, slope is 0, so it is rest. So here an object in uniform motion, uniformly it's increasing, but if you see here object is in non-uniform motion, if I take a point here and if I take a point here, no, it will be different. Like if you see here, no, it has been increasing uniformly, but here it is non-uniform case. Okay, 3 diagrams are there. One is stationary, uniform, non-uniform for position and time graph. How I can say like it's a uniform motion, like why you are saying this is uniform and why this is not uniform? I mean, if I take a slope here, if I consider this point and this point, no, if I take a slope, angle will be same, right? But if I see here, if I take this point and this point, angle will be different. Angle will be different. It can be less than or greater than whatever it is, but it will be different angle. Right now, considering the slope, I am saying that it's a not uniform. If angle is same, it's a uniform. Angle is not same, it's a non-uniform. Here slope is 0, right? Slope 0, constant slope, it's a variable slope. That's it. Got it? Done. The next thing is average velocity. We have seen, no, average velocity. So now average velocity is nothing but change in displacement with respect to time, right? No, so if position changes with respect to time, I can say, right now displacement by time is velocity, position, change in position with respect to change in time is average velocity. Now if you see here uniform velocity, no, uniform velocity in the sense, wait a minute, yeah, so velocity is nothing but displacement by time. So position with respect to time should be the graph, right? No, position with respect to time. In the previous case it is position time graph, no. So uniform velocity in the sense it should be like slope should be constant, right? Now if I see here slope is constant, yes, slope is constant, it is rest, no, it is rest, live about rest or it is motion, but slope is constant. See here slope is constant, right? If you see here slope is constant, here it is 0, here it is less than 90, here it is greater than 90. Yes, no, if I take a horizontal line here and if I draw a line, sorry, wait a minute, yes, yeah, yeah. So if I take a horizontal line, if I take an angle, no, it is greater than 90. So negative slope, positive slope, and it is 0. But it's a constant slope, na? It's a constant slope. Got it? You can take a note of this. Done, no? So next is, yeah, position time graph, uniform motion. So uniform motion we have seen the same thing, okay. So here if you take slope, it is constant. That we say uniform motion. Okay. So next one is velocity time graph. That's of uniform motion. Okay, that's of uniform motion. So when we are taking a velocity versus time and we are taking area of that. So what is the meaning of area is, I will multiply y axis with respect to x axis. Okay. So what I am getting is, I will do the derivation here and you give the answer here. Okay. So if I take velocity into time, what I will get? Displacement, right? So what is velocity? Meter per second. What is time? Second. Second cancel, only meter left out now. So which is nothing but displacement, right? No. So when I take a area of the velocity versus time graph, I will get displacement. So taking area for VT graph gives displacement. Okay. But when you take the slope for VT graph, will give acceleration. So what is slope? A tan theta. Tan theta is nothing but y by x. Okay. Area is y into x, but tan theta is y by x. Okay. So tan theta is y by x, which is nothing but meter per second by second, no, which is nothing but meter per second square, which is acceleration, no, acceleration. So tan theta gives, tan theta is slope, no, which is nothing but acceleration. So area gives displacement, but slope gives acceleration for velocity time graph. Okay, take a note of this. Got it? So till now we have seen xt graph and vt graph. Okay. So the basic thing you should understand is xt graph, vt graph, slope, area. Okay. For xt graph, if I take a slope, I will get velocity. Slope is nothing but x by t, no, displacement by time, velocity I will get. For vt graph, I will get acceleration. But for area of xt, I won't get anything. But area for vt, I will get displacement. Okay. For at graph, slope is rate of change of velocity. Okay, rate of change of velocity. Rate of change of velocity. But what about area? Area gives velocity. You can take a note of this in a tabular column. xt, vt, at are the graphs. Done? Got it? Done, no? We'll go for the next thing. So area we completed, no. Now position time graph, uniformly accelerated, uniformly decelerated. So uniformly accelerated means, so positive slope, it is accelerating uniformly, like angle has been increasing, no, uniformly, no, yes or no. But if you see here, uniformly decelerated. Okay, this is the graph for uniformly accelerated, graph for uniformly decelerated, and this is for uniform motion, like say, like angular same. Okay, angular same. Take a note of this. Got it? Can we go for the next one? Done. So velocity time graph. So motion is positive direction with positive acceleration, motion with positive direction but with negative acceleration. So here positive direction only but negative acceleration, here positive direction but positive acceleration, it's increasing, no, angular increasing, its angle, if you see the, leave about the angle increasing decreasing, but if you see here, angle is positive, angle is negative, more than 90, less than 90. Okay, like a constant only, no, constant slope, like angle is not increasing, angle is same here. Okay, and sorry for that, angle is same here. Okay, so it's a less than 90 angle, greater than 90 angle, so it is decreasing acceleration, I mean negative acceleration is a positive acceleration. Okay, and when you see here, motion is negative direction and negative acceleration. So when I take a line, horizontal line, if I take an angle here, it is greater than 90, no, yes or no, can I draw it? I will draw here. So if I take a horizontal line, if I take an angle over here, it is less than 90, so theta is less than 90 degree, here theta is greater than 90 degree, so it is negative, so it is positive. Okay, both are in the positive direction, but here positive acceleration, negative acceleration, it is negative direction but it is, if you take angle, theta is greater than 90, right, no, negative acceleration. Here motion with negative acceleration and between 0 to t1, between 0 to t1 and positive x axis, and between t1 to t2 in negative x axis. Okay, up to here it is positive x axis, up to this one is negative x axis, no, but what is the acceleration? Negative acceleration, because if I take here, angle is greater than 180, sorry, greater than 90, if I take an angle here, it is greater than 90, 90 negative acceleration, but up to t1 it is positive direction, t1 to t2 negative direction. Okay, if you want you can take a note of this. Done. Hi. You can note this first. Excuse me. Completed. We'll see next one. So special cases. So first one, when two objects move with equal velocity. So equal velocity means angles like slopes are equal. Okay. Then when the two objects moves with unequal velocity, so slopes will be different over here. Okay. At some point they velocities will be, the position will be metered, the object will be metered, we'll say. Okay, the object has been metered at some point, so this is the meeting position, we'll say. Okay, when VA less than VB, if I take a slope, okay, if I take a slope, I can say whether the velocity is less than or greater than. So here, so this is my B and this is my A. Okay, this is my B and this is my A. When I take a slope over here, I will get velocity of A is less than velocity of B. Okay, you can take a note of this. So with this we'll conclude the session and we'll do problems on graph in the next upcoming classes. Okay, and then we'll continue with the motion in a plane. Done? Okay guys, bye bye, we'll meet in the next class. So whoever want to take a screenshot of this, you can take it, and whoever want to note this, whoever watching in offline can note this. Okay, first I'll give 15 seconds time. Fast. Each 5 seconds, huh? Complete it. Okay, we'll conclude this session. Bye guys.